that on hand. And we are going to set it up and take a look at the wavelength in motion. Now, what we're primarily looking for is not only how the wavelength moves, but its amplitude and its frequency, which we'll talk about once we're done. My kitchen worked out great for this because it has a grid built into the floor. I've got these tiles, which is going to be great when we try to go back and look at what we did. I also have some little pieces of blue tape that I'm going to mark on my floor equal distances apart. This is going to measure my amplitude, right? Because this is my string or my wave at equilibrium when it hasn't moved yet. And my amplitude is going to mean the distance from equilibrium that I move on either side. So I'm going to want to have two different amplitudes. So I'm also going to mark a distance that's a little bit further apart. And since I'm using a grid, it's going to be really easy for me to tell that I have these pieces of tape in the same spot on either side of equilibrium. Okay, so I'm going to take my string, I'm going to give it a good shake between my lower amplitudes. I want to make sure my string goes slow, and then I'm going to move it fast and increase the frequency. I'm going to repeat that same process, but moving it to my larger amplitude. Again, starting off slow, and then moving faster. Here's the first one we did with the lower amplitude. You see I'm starting with a low frequency, not moving my hand very fast, and then I'm speeding up. Notice that all of that energy going through the rope is coming from my hand and is moving towards the other end of the rope. For this next one, you can see that we increased the amplitude. We still started slow, and then we're going to speed up. You can see the wavelengths are getting shorter. There's more of them happening at one time. I'm forcing more energy from my hand to the other end of the jump rope. So what was all that about? Well, we made our own wavelengths to see how the energy we put into making that wavelength affected its amplitude and its frequency. So let's break it down a little bit, talk a little bit about amplitude, talk about frequency, and how the energy is moving through that wave. So in terms of amplitude, remember we had talked about this line representing the equilibrium, so when the wave is not moving. Now when the wave starts moving, it moves from equilibrium either further or closer. So if something has a small amplitude or less amplitude, it is not going to have very great of a distance between the crest in equilibrium or the trough in equilibrium. That is going to have a low amplitude. Now, a medium amplitude is going to be slightly bigger. Now, we're not messing with the wavelengths here. We can keep the wavelengths the same, but increase the amplitude. Notice how now we have slightly more distance between the crest and equilibrium and the trough in equilibrium. So if we let our amplitude get as big as we can get it, then we should see not a change necessarily in the wavelength, but a taller amplitude. So that distance between crest and equilibrium and trough and equilibrium. So here you can see we have a much greater distance between the crest in equilibrium and the trough in equilibrium. Let's take a look at frequency. We're gonna have to start over though. All right, now we're ready to talk about frequency. So frequency is going to be literally how frequent those wavelengths are. So if we have a low frequency, we're going to have wavelengths that are less frequent. So they're going to be further apart. That crest to crest is going to be a lot further apart. Okay? So we don't even have a whole wavelength here. Because remember, wavelengths are measured crest to crest or trough to trough. We have about half of a wavelength here. So if we're going to increase the frequency, we're going to increase how many wavelengths we're seeing. So here you can see that we have a full wavelength. We can go crest to crest. So we're going to have slightly higher frequency. Now, in theory, these amplitudes could be the same, but we're getting more wavelengths in that given period of time. So the highest frequency, we are now seeing one whole wavelength, crest to crest, trough to trough, plus part of another wavelength. So we have a low frequency, medium frequency, and a high frequency. And when we do that, we are increasing the number of wavelengths in a given period of time. Okay, so basically it's saying that if you had a wave going like this, it's how many wavelengths pass my finger in 1 second. Okay, so amplitude is the height of the wave from equilibrium. Frequency is the number of wavelengths passing a certain point. Now, what does all of this have to do with energy? Energy is what is carried by the wave, and it moves. So our energy is what is being moved along the wavelength. So if I have less wavelengths, I am moving less energy. And if I have more wavelengths, I'm going to be able to move more energy. Now, that is related to amplitude. Both amplitude and frequency, when they increase, typically increase in the amount of energy. Now, in the little investigation we did, we noticed that when we increased our frequency and we moved our hand faster, that energy came from our hand, okay, and then went into the rope, and that energy was passed down. If you had another person holding on to the other end, you can ask them, was it harder to hold on to the rope when I was moving it faster? And they will say, yeah, it was, because you now have more energy going through that rope. So, relationships between amplitude, frequency, and energy. If we have more frequency, we're going to have more energy. And typically speaking, our amplitude also increases when we increase our energy. And that is our lesson for today.